Hello guys, I'm back again with a new research article that is wireless end-to-end image transmission system using semantic communications. In the previous video, I have started semantic communications. We have discussed about the abstract, how does the idea of semantic communication come, and challenges applications of semantic communications. I am back with one more article which is related to semantic communications, that is end-to-end image transmission system using semantic communications. I hope you liked my previous video of semantic communication. This is one more research article we will discuss today. So topics to be discussed in this video. We will discuss different topics. Number one is we will discuss wireless end-to-end image transmission system using semantic communications. Then we will discuss about the abstract of this article, and in the next we have the introduction of wireless end-to-end image transmission system. Then I will show you the preliminary system model for semantic communications, and in the end I will explain you the bifurcation of semantic communication and the characteristics of semantic communication. Understood it? So number one is abstract. So semantic communication, it is the future of mobile communication, and its main motive is to transmit the semantic meaning of the data. Like in Shannon's method of communication, we have seen that data is transmitted by bit reconstruction. Okay, means the data is transmitted either in the form of bits or in the form of symbols. But in case of semantic communication, only the semantic meaning of the data is transmitted at the receiver's end. Understood? So it bridges the gap of limited bandwidth problems. Like in Shannon's theorem of communication, you can see that data is not transmitted at the limited bandwidth. That means bandwidth is required much higher. But in case of semantic communication, it overcomes the problem of limited bandwidth, and the data is transmitted at the limited bandwidth even we have high volume of data to transmit. Clear? So if we are integrating AI with 6G, right now in the future mobile communication we will integrate AI technologies with 6G communications, and it will pave the way to develop semantic communications which is based on end-to-end communication system. Means data is transmitted from the transmitter to the receiver side using AI and 6G. Okay. So in this study, in this research paper, we will see that the semantic communication based end-to-end image transmission system, and we will discuss about the design considerations, uh, how to develop the model of semantic communications in the system with physical channel characteristics. That means we need to have a decoder, encoder and a channel to transmit the information, semantic information from the transmitter to the receiver. Got it? Then we have a GAN network. GAN is generative adversarial network. It consists of two parts. That is, it consists of one discriminator, and the GAN network generates two types of images, fake images and real images, and the GAN network selects only the real images. So it is used at the receiver side to reconstruct the realistic image, means to identify the realistic image at the receiver based on the segmented image, semantic segmented image. Okay. So it is placed at the receiver input. Then we have the semantic segmentation task at the transmitter and the GAN network at the receiver both. The segmentation task at the transmitter means at the encoder we can say, and the receiver we are having decoder. So the GAN network is built at the receiver side and the semantic segmentation task is given at the transmitter side, means to the encoder. They both are trained on a common knowledge base, and that is COCO stuff data set. Okay. Then the research shows that the resource gain in the form of bandwidth saving is immense, is huge. That means by using semantic communication, by training the GN network and the semantic segmentation task, we can save the bandwidth in a very larger way. That means we can send our signal, send our data in a limited bandwidth when transmitting the semantic segmentation map. Okay. Then the research studies the effect of physical channel distortions. That means when we are transmitting the signal from the transmitter to the receiver, there will be noise, there will be distortions in the transmission of the signal. So it will study the effect of distortions or the noise while transmitting the data on semantic, based on semantic communication. Okay. Next, come to the introduction of semantic communication. So the key challenge, what is the key challenge in this semantic communication? We need the limited bandwidth and we need the, as the data is increased, so only the required data is to be transmitted from the transmitter to the receiver. So traffic is very high and wireless sensor networks and IoTs are very high, means they are rapidly increasing. These devices are rapidly increasing and they will create the problems in managing communication networks. So they will create the problems ultimately in semantic communication too. So what is the nature of media? It is very complex and the communication system has led to the increase in its bandwidth and energy demands. The data is increasing, the media is very complex, so we need to increase the bandwidth and energy demand, but semantic communication helps us in reducing the bandwidth and sending only relevant data at the receiver side. So sustainability need to be applied all over the systems, so that we need to reduce the resource utilization. We need to reduce the large number of resources. We need to save our resources. We need to save our energy and we need to save our bandwidth. So the key requirement, I told you, bandwidth we need to reduce, and as we know that in media transmissions, wireless sensors, networks and IoTs, different network technologies such as IEEE 802 standard 6G and 5G systems, we are using these technologies. Together with, we need to reduce the traffic load. Okay, because the multimedia media is very high, the data is very high, so we need to reduce the traffic load while communication. Okay. Next, we have the semantic communication has renewed academic and industry. That means all over the world, the semantic communication people are interested. They have renewed interest. They have generated their interest, and the industrialists also, they have generated their interest in semantic communication. And due to promising possibilities, it allows to go through beyond Shannon's capacity limit in bandwidth. That means in Shannon's theorem, we have seen that the bandwidth is not limited. It requires higher bandwidth to transmit large number of data. But in semantic communication, it has the capacity to limit the bandwidth. So the objective of the semantic communication is to deliver the semantic meaning of the message, not to deliver the bit by bit transmission of the signals. Okay. And next we have the applications and the benefits of higher bandwidth are very high. We know that super high resolution is there. Video, we can transmit videos, 3D videos, AR VR streaming we can do, but these approaches are have less gains as compared to the machine to machine communications, okay, like WSNs and IoTs. So yet overall with the semantic communications concepts we need, it is expected that we can reduce the bandwidth, the complexity of the data transmission, and the increase in the range, and we can enable the longer operational cycles, means the data can be transmitted over longer time in battery powered devices like WSNs, IoTs, and M2M communications. Okay. Next, the traditional communications is only focused on transmitting minimum number of bits, like Shannon's theorem. It is only focused on transmitting minimum number of bits, and with the error should be least between the 2 points. Like the Shannon's presented the original paper in 1948, and it has the proof that the all rates below capacity are possible without higher number of errors at the receiver side. That means in Shannon's original paper, the errors for during the transmission of signals are very less at the receiver's side. So after that, there has been a lot of research on the source on channel coding, and it is still a matter on the transmission side. So they suggested three levels of communication, three levels in the communication system. Number one is the technical problem. We can have the semantic problem and the effectiveness problem. So number one is the technical problem. It pertains how the symbols of the message are transmitted. That means we are having the message, how the symbols in the message are transmitted. If the signals are not transmitted in a proper way, there will be technical problem while communicating the data. And in the semantic problem, how effectively the transmitted symbols convey the meaning of the message, means the symbols are transmitted, but how effectively they are giving the message. Like I am at the receiver, how effectively I am understanding, I am conveying, I am getting the meaning of the message that is to be transmitted. Effectiveness problem, that means how effectively the transmitted symbols are doing the intended task, whatever the task is given at the input signal, whether they are performing the same task at the receiver, intended task at the receiver or not. Clear? In semantic communication, it is planned to address the second layer, which is semantic problem, and in the Shannon's theory, only the technical problem was concerned. So next we have the semantic model for system model for semantic communication. So figure 1, I will show you the figure. It illustrates, I will show you a preliminary system model for semantic communication for text as well as speech and image transmission. So here we have one transmitter which extracts the semantic meaning of the message from the image or whatever the data is given to it and applies channel coding to the bit stream, and then it transmit it over the one channel is there, and the semantic meaning of the message is transmitted through the channel. On the receiver side, we have a channel decoder, and it decodes the signal semantic information from the received signal. Then we have semantic decoder. It takes the semantic information, and the semantic information is transmitted through the channel. It is considered as the input, and it will generate the output with the existing knowledge base. Whatever the knowledge the decoder has, it produces the output on the basis of that, and the knowledge is shared between the encoder and the decoder previously. So the challenge is, what is the challenge in transmitting semantic communication? What is the challenge in transmitting the data with the help of semantic communication? So the challenge is to ensure that the transmitter semantic information is preserved at the receiver while transmitting through the physical channel. Transmitter cannot delete the information. So a significant amount of research has also been done over different types of media, different types of communications. So this is the figure, the preliminary model of semantic communication system. So you can see the image, the semantic coding, channel coding, and the channel encoder is given. And channel coding is known as encoder, channel decoding is known as decoder, and the semantic decoding is done. And the image is produced with the help of semantic decoding at the output. So I told you the source extracts the semantic meaning of the core characteristics of the content. Okay. And in channel encoding, this semantic information which is extracted is encoded for transmission over a noisy channel. Maybe the channel is noisy, may or may not be. Then the encoded semantic information is sent through the network, and at the receiver the semantic information is interpreted and reconstructed to achieve the original intended meaning of the signal. Understood? Then we have semantic communication. Here I will explain you about the characteristics of semantic communication system. So this research aims to develop a semantic communication system. To what is the benefit of developing a semantic communication system? To transmit images over a mobile communication system. Okay, the images are in the form of data, or we can say the data in the form of images is used to optimize the bandwidth, to reduce the bandwidth, and the quality of the image is also maintained. Clear? A semantic map is extracted from a given image. That means the data is extracted in the form of a map. We can say it as a map, the input, we can say it as a map, and it is the channel encoded in channel encoder, and it is sent over a noisy channel to the decoder for further extraction, for reconstruction and interpretation. At the decoder, the semantic bit stream is channel decoded in channel decoder, and it is as an input to the GAN, which is generative adversarial network. It has a discriminator. It produces two types of images, fake images and the real images. The discriminator identifies only the real images and produces the real images at the decoder. Okay, and the common knowledge of images are shared between both encoder and decoder. So to reduce the amount of data only, we need a semantic map of image is sent through the channel. Means the whole amount of data is not extracted for the channel encoding. Only a semantic map of image is sent through the channel. Okay, so what is the result of this? There will be the reduction in demand energy and wireless bandwidth. Means energy will also reduces and the bandwidth of the signal will also reduces. So the communication network will be more sustainable. Okay. Then we evaluate the influence of channel coding on semantic communication. Okay, in the presence of noisy channel, and we use the polar codes for this as our channel coding scheme. So code words are modulated, means their characteristics are enhanced and they can be traveled over longer distances using binary phase shift keying, that is BPSK, over an additive wide Gaussian noise channel, AWGN. Clear? At the receiver end, the noisy low likelihood ratios are, means the noisy channels are, the noise or distractions are fed to the decoder. The decoder computes only the estimated code words. Clear? So there are three types of scenarios. In the first scenario, the impact of noise with zero channel noise is evaluated. Means there will be no noise. In the second scenario, the impact of varying channel noise on virtual channel. That means noise may be different on different channels. And finally, in the third scenario, the impact of combined quantization noise levels are detected on the virtual channel. So the maximum amount of channel noise that can be present for effective desired semantic communication we have inferred from this, and we have demonstrated that the edges of semantic maps is crucial in designing future communication systems that rely on semantic. That means we have performed some experiments to derive the maximum amount of channel noise that can be present for effective semantic communications, the value we have derived. So in the hand, the peak signal to noise ratio, which is PSNR, is calculated for the transmitted image at the receiver side for comparison. At the receiver, the noise ratio, peak signal to noise ratio, is calculated. So JPEG images are transmitted. So the researchers have conducted a subjective experiment using a sample of 30 users of different socio-economic background. Clear? They have evaluated they have conducted a research, an experiment to sample 30 users that are from the different socio-economic background, and the results are calculated at the receiver side. Understood? So this is enough for today. I have explained you the semantic communication, how end-to-end image is transmitted. We have seen the preliminary system model for semantic communication. I hope you understood it. And please don't forget to like, share and subscribe. I'll be back with some more videos. Stay tuned to my YouTube channel, and thank you. Have a nice day.